Welcome to The Explainer. Sometimes you come across a question that just sounds like pure science fiction, right? Well, today we're tackling one of those, but it's got its roots deep in real astrophysics. We're going to explore whether the biggest, baddest explosions in our solar system could actually mess with time itself. So, here it is, the big question. Can a solar flare, one of these unbelievably violent explosions, actually let us travel through time? I mean, seriously. But before we can even start to unpack that, we've got to get on the same page about what we're even dealing with. Okay, so let's start with the basics. Before we get into bending space-time and all that fun stuff, what exactly is a solar flare? So at its heart, a solar flare is just a massive, massive explosion on the sun. Picture this. The sun's magnetic field lines, which are incredibly powerful, get all tangled up. They stretch, and then they just snap. And when they do, a truly mind-boggling amount of energy is released in just a few minutes. It's wild. And the stuff that gets thrown out, it's just staggering. You're talking about radiation across the entire spectrum, everything from radio waves all the way up to gamma rays. Plus, you get this storm of charged particles blasting out at almost the speed of light. A lot of the time, this comes with something called a coronal mass ejection, a CME, which is literally a billion-ton cloud of plasma getting chucked into space. But here's the kicker, the really important part for our discussion. All that energy, all that stuff moving so fast, it actually subtly warps the very fabric of space-time. Yeah, for real. Okay, so now that we know what we're dealing with, let's talk about going forward. Can a flare help us travel into the future? And believe it or not, this part isn't science fiction. This is real, thanks to a little guy named Einstein. It all comes down to this absolutely wild concept called time dilation. It's one of those things that breaks your brain a little, but it's totally proven physics. The gist is this: the faster you go through space, the slower you go through time compared to someone who's just standing still. Simple as that. Well, maybe not simple, but that's the core idea. Okay, so let's put this into perspective. Imagine we could build a probe that could surf the particles from a solar flare, right? And it gets accelerated to, say, 99% of the speed of light. Well, for every 1 year that passes for that little probe, 7 years would have gone by back here on Earth. So when that probe comes back, it's literally landing in our future. So yeah, traveling forward in time, it's not a fantasy. It's just physics. All right, so the future is possible. But what about the holy grail of time travel? Can we send messages to the past? Okay, big disclaimer time. This is where we leave the solid ground of what we know and start wading into the deep, deep waters of theoretical and speculative physics. So everything from here on out, super cool ideas, fascinating theories, but absolutely not established fact. Got it? Good. So just to recap, riding flare particles for forward time travel, that's real physics based on general and special relativity. But what about these other wild ideas? Well, there's the concept of using the plasma itself to kind of hold on to a signal and release it later. That's speculative. Then you get into the really out there stuff, like maybe, just maybe, the sheer energy could create a tiny wormhole for backward travel. That's highly speculative. It works on paper, maybe, but there is zero, and I mean zero, evidence that it can actually happen. Okay, let's have some fun with this. Let's imagine we're some super advanced civilization. How could we actually try to build something with these concepts? Could we really make a solar time capsule? I love this first idea. It's basically like creating a message in a solar bottle. Now, this isn't about going back in time. It's about using the sun's crazy plasma to store a message and have it delivered at a later date. So how would this even work theoretically? Well, step 1, you'd beam some kind of signal right into a plasma loop that's about to erupt. Step 2, the flare's insane magnetic field would trap that signal, bouncing it around inside like a pinball. They call this a plasma echo. And then, step 3, hours, maybe even days later, when that magnetic loop finally destabilizes, poof, it spits the signal back out. For someone on Earth, it would look like a message from the future just appeared out of nowhere. Now, the second method is a bit different. It uses the physics we already talked about, the stuff we know is real, time dilation. But instead of sending a person, you'd send a little packet of data on an absolutely epic journey. Here's the plan. You'd have a probe just waiting for a huge coronal mass ejection. It would basically hitch a ride, getting caught up in this billion-ton plasma storm and accelerated to a huge fraction of the speed of light. And as it's zipping through space, remember,
time slows down for the probe compared to us back on Earth. So when it finally makes its way back, it's delivering its message to an Earth that could be years, decades, even centuries in the future.
Okay, this is all fantastic stuff to think about, right? But how real is any of this? Let's bring things back down to earth for a reality check. Let's just get this out of the way. The number of ways we know of to send any kind of useful information into the past, it's a big fat zero. Nada. The fundamental laws of physics, especially this really important one called causality, the whole cause has to come before effect thing, pretty much slam the door on that idea. And hey, even for those more realistic ideas like the time capsules, the roadblocks are just immense. First off, solar flares are completely chaotic and unpredictable. You can't just order one up. The energies involved are just astronomical, totally uncontrollable. Any tiny time effect you might get would be so small it would be completely buried in all the cosmic static and noise. And the engineering? It's so far beyond anything we can currently build, it's not even funny.
So you might be asking, well, if it's impossible, why are we even talking about it? And that's a fair question. But here's the thing. Thinking about these crazy extreme scenarios is actually one of the best ways scientists push our understanding of the universe. It makes us connect what we see in a lab, like those little plasma echoes, to these gigantic cosmic events. It's all about pushing the boundaries and dreaming up the next big question.
When you boil it all down, these ideas show us something truly incredible. In theory, a star could be a kind of cosmic hard drive, a time capsule waiting to be used. So I'll leave you with this final thought to chew on. If you could use our sun to send one single message to the far, far future, what message would you send?